Let's start off by summarizing the mole facts that we should know up to this point. The atomic mass or molar mass of a substance allows you to convert from moles to grams or grams to moles. To convert from moles to atoms or molecules and vice versa, use Avogadro's number. 6.02 times 10 to the 23rd atoms or molecules in 1 mole of a substance. Okay, let's use these mole facts to solve some problems involving solids. You have 10.5 grams of silver in a beaker. How many moles of silver is this? Take a look at your mole facts. Is there a way to convert from grams of a substance to moles of a substance? Looky here. The atomic mass allows you to convert from grams to moles. So now, set up the problem. Start with 10.5 grams of silver in your train track. This calculation should only take one step because the atomic mass allows for the conversion of grams to moles. There are 107.9 grams of silver in a mole of silver. Grams need to cancel. So 107.9 grams needs to go on the bottom, which means 1 mole of silver goes in the top part of the train track. Doing this causes the grams of silver to cancel. To perform the calculation, multiply the numbers on the top of the train track and divide by the numbers on the bottom of the train track. In this case, all we need to do is take 10.5 and divide by 107.9. This calculation gives 0.0973123 moles. However, the answer can only have 3 significant figures because the number given to us in the problem, 10.5, only has 3 sig figs. 10.5 grams of silver is 0.0973 moles of silver. Now you try one. The setup for this problem is exactly like the previous example. Pause the video and use the mole facts to determine the number of moles in 9.56 grams of baking soda. Remember, showing your work with units and labels is more important than writing the answers to the question. Here is the work and the answer, with the appropriate number of sig figs, of course. How about another one? We have a spoonful of sugar, or 4.78 grams of sugar, and the problem asks for molecules of sugar. Start by looking at the mole facts. Is there a conversion that allows you to convert between grams and molecules? Nope. The only conversion factor with molecules in it is this one. 1 mole is Avogadro's number of molecules. No problem. Is there a way we can convert from grams to moles so that we can use Avogadro's number? You bet. We can use the molar mass to convert from grams to moles. This problem requires the use of both of our mole facts so far. Start by converting the grams of sugar to moles of sugar. Then convert the moles of sugar to molecules of sugar. Start with 4.78 grams of C12H22O11 in your train track. This conversion will take 2 steps, so my train track will be a bit longer. Our next step is to convert grams to moles. There are 342 grams of sugar in a mole of sugar. Grams need to cancel, so 342 grams needs to go on the bottom, which means 1 mole of C12H22O11 goes in the top part of the train track. Doing this causes the grams of sugar to cancel. If we stopped right here, we would only calculate the moles of sugar. The problem asks for molecules of sugar. So we need to use Avogadro's number. 1 mole of sugar contains 6.02 times 10 to the 23rd molecules of sugar. Moles must cancel. So 1 mole of sugar will go in the bottom section of the train track, which means 6.02 times 10 to the 23rd molecules of sugar goes in the top section. This causes moles of sugar to cancel, leaving us with molecules of sugar. Perfect. To perform the calculation, multiply the numbers on the top of the train track and divide by the numbers on the bottom of the train track. In this case, we need to multiply 4.78 times 6.02 times 10 to the 23rd. Then divide by 342. This calculation gives a very large number, 8.4139 times 10 to the 21st molecules of sugar. The number given to us in the problem has 3 significant figures, so the answer can only have 3 sig figs. The correct answer to this problem is 8.41 times 10 to the 21st molecules. Hey, now you try one. The setup for this problem is exactly the same as the previous example. Pause the video and use both mole facts to determine the number of molecules in 0.0450 grams of gold. Showing your work with units and labels is more important than writing the answer to the question. How'd you do? Here's the work and the answer with the appropriate number of sig figs. Let's try one more type of mole problem. You have 4.02 times 10 to the 23rd molecules of salt from your trip to the beach. How many grams of salt is this? This problem is very similar to the last problem. In the last problem, we started with grams and converted to molecules. In this problem, we are starting with molecules and converting to grams. This means we will need to use both of the mole facts we know so far. We can use Avogadro's number to convert from molecules to moles, and then use the molar mass to convert from moles to grams. Let me show you. Start with 4.02 times 10 to the 23rd molecules of salt in the train track. My train track is going to be longer again to account for this 2-step conversion. Our next step is to convert molecules to moles. There are 6.02 times 10 to the 23rd molecules of salt in a mole of salt. Molecules need to cancel. So 6.02 times 10 to the 23rd molecules will go on the bottom of the train track, which means 1 mole of NaCl goes in the top section. Doing this causes the molecules of NaCl to cancel. The problem asks for grams of salt. If we stopped right here, we could only calculate the moles of salt. So now we have to use the molar mass to convert from moles to grams. 1 mole of NaCl is equal to 58.5 grams of salt. Moles must cancel. So 1 mole of NaCl will go in the bottom section of the train track, which means 58.5 grams of salt goes in the top section. This causes moles of NaCl to cancel, leaving us with grams of NaCl. Excellent. To perform the calculation, multiply the numbers on the top of the train track and divide by the numbers on the bottom of the train track. In this case, we need to multiply 4.02 times 10 to the 23rd times 58.5, then divide by 6.02 times 10 to the 23rd. This will give us 39.065 grams of salt. Once again, the number given to us in the problem has 3 significant figures, so the answer can only have 3 sig figs. The correct answer to this problem is 39.1 grams of NaCl. Hey, now you try one. The setup for this problem is exactly the same as the example I just worked. Pause the video and use both mole facts to determine the mass in grams of 25 molecules of ozone. Showing your work with units and labels is more important than writing the answer to the question. Here is a hint for this problem. The answer you get will be very small. Here is the work and the answer with the appropriate number of sig figs. How'd you do? Coming up next, I will introduce you to another mole fact that you can apply to liquids. So stay tuned.